Welcome back. In this section, we will learn the object-oriented interface of matplotlib, subplots, and ScatterPlot. So, if you look at the anatomy of a figure in matplotlib, you can go to matplotlib.org and just find out the anatomy of a figure. Most of the things we have covered. This is your figure, and you'll have on the Y label here. This is the Y-axis. This is the X-axis. You can have ticks. You can have major ticks. You can have minor ticks on both the side. Okay, and these things are called spines, and you will have axis, and your plots will come here. So far we have just plotted just a single plot in a figure. We have not divided a figure into multiple subplots. We can do that. So let's import the libraries, and I have already imported this library, and the way you are going to use your object-oriented interface is through this particular axis class. Okay, so if you do a plt.subplots with the default value, you are going to get two variables. One is the figure, second is the axis. Now, since we have not passed anything here, how many subplots you want, by default it will give us one. If you do the print of the type of AX, you will get a matplotlib.axis.subplots, and you will get an empty figure. And if you basically an empty plot, and if you look at the type of the figure, you're going to get this particular figure class. Okay, so let's see how to divide this figure into multiple subplots. So in this subplots, you can mention the number of rows that you want, suppose 2 rows and 2 columns, and you can mention the figure size. And I'm going to print the AX. So I'll get 4. So this is how you will get a 2-dimension output back. Okay, this AX is 2-dimension. This is your 0th plot, the first, the second, and the third. So it starts from in indexing in Python starts from 0. So these are the 4 plots that you get. Okay. Now, since we want to access each of these plots independently, so let's just take 2 plots for an example. 1 row and 2 columns. Or 2 rows and 1 column, whichever way you want. We are going to give the output here we are going to get those many variables, and since I don't want to type AX01, AX02, I'm going to unpack the data here itself. Okay, and let us have a few data points. So suppose you have X from 0 to 6 with a step size of 0.5, Y is a sine wave. Let us take Z as a cosine of X, and let us plot them. So there is just subtle differences between your plt.plot and your axis.plot. So ax.plot ax2.plot x comma z. We are also going to use the plt itself, the tight layout. So you would see in 1 row and 2 columns, in one you have your sine wave, in another you have the cosine wave. and you can set for each of them. So you will have this axis, the x-axis for the first subplot, y-axis for the second subplot. Okay. Now, if you want to access individual methods, you would have to do ax dot, and like for example the h line, it was plt dot h line. Here it is just ax h line. So there are just subtle differences, not too many, just some of the functions change, otherwise most of the functions remains the same. So for the first axis, you want a horizontal line at y is equal to 0. Similarly, for the second, you want a horizontal line at y is equal to 0. When you want to set the labels, so instead of doing a plt dot x label, you can say plt dot ax2 dot set x label and y label. Okay, some of the function there is some subtle differences, but this is the way you can use your object-oriented programming in your matplotlib. This actually should be used. It's quite helpful, and helpful in the sense that you can customize your plots a lot. Okay, and in this way you can create n number of subplots within your bigger plot. Suppose you do not want to use the object-oriented interface. What you can do is you can directly use the plt.subplots. The first thing is number of rows, second thing is number of columns, the third thing is the plot number on which you want to do the the current plotting. So one row, two columns, and first plot. I'm trying to mimic what we did earlier. So I have plt.plot x comma y and plt.hline y equal to 0. And on the second, plt.subplots, first row, one row, two columns, and the second plot, the plot number 2. Okay. Okay, within the h lines, you would have to give the x min and the x max, which position you want to start your line to be, and at what position you want your line to end. So I'm starting at a minimum. So my plot is from 0 to 6. I want to minimum and maximum. So this is the span. Unless I've made some mistake, it doesn't take this much time. There's some issue with my h lines. We'll see that separately. Sorry, it is subplot, not subplots. Okay, this is subplot. The function subplots will return you figure and your axis. This is just the function subplot without the plural. So you will get these two plots, and you can you can give the plt.figure size like the earlier one, 15,4. So by first row, 2 columns, 1 row, 2 columns, and the first plot, 1 row, 2 columns in the second plot. Okay. The same result you can get with the plt.subplot function. Only thing we use AX is to get a better handle. So when we will see animation, that is the time we are going to require the object-oriented interface. We are going to use this object-oriented interface and then perform animation. Okay, so there are two ways to do your subplots. Now the scatter plot is quite simple but very useful in machine learning, where you're trying to find the correlation between two data points. So it is a just between two data points when you do not want line etc, just to see the relation between them. Are they positively correlated or are they negatively correlated? Okay. This is some very simple data, and you can do a plt.scatter. You will get a scatter plot between x and y, and it will show the correlation. X and y must be of the same size, so I'm starting from 1 going up to 10. So I need to start from 11, go up to 20. So my data points are same. So this is perfectly correlated. Okay. In real life, you will not get this kind of data. You will get data which are probably somewhere like this. So basically, once you import your data into pandas, and you will have two columns, two data series which you would want to then further check the correlation. That is how you can use this scatter plot. This is a visual way of correlating data. Okay, you can visually see it. The numerical way of it is just np.core function. You can use the core function and find out the correlation. Correlation coefficient is between -1 to 1. Okay, -1 being perfectly negatively correlated, +1 being perfectly positively correlated, and 0 being no correlation. When there is no correlation, your data would be in a horizontal line. So there's no correlation between. So how much ever x you change, y is not changing. Okay, y is still constant. That is when we say there is no correlation between data. Okay. I hope this helps. I'll meet you in the next section.